Okay, what it wants us to do is basically say, okay, let's just break it down into its like smaller pieces is basically what it means, and then we're going to try and develop the power rule again, I suppose, but not that big of a deal. We already know what power rule is. It's just a little extra practice. Okay, so we don't necessarily have to do this whole thing, but if anybody was away on Friday or you've forgotten since then, this is the same thing as saying x times x, which turns into, we know, as being x squared. Now, expanded form is particularly useful if you're stuck on something, okay? It's very literal, right? That's what the expanded form is. So something like x squared will turn into x times x. And then I'm going to multiply that against x times x times x. And how many x's do you count? How many in total if they're all multiplied together? There is 5 x's, so we get x to the power of 5. And so your little power rule, which we did the other day when you're multiplying things of the same base, in this question the base being x, we added the exponents. Okay? And then there are some little subtle things, like this is not an exponent of 0, okay? Because we know anything to the exponent 0 would be 1, so that's not the case, otherwise it would just be a 1 there. This is actually x to the power of 1. Okay, and so again, we're just going to add the exponents, so we're going to get x to the power of 4, and if we were to write that out, you'd get x times x times x multiplied by x. There's 4 x's there, so it's x to the power of 4. Okay. Just trying to hit home this idea of the expanded form, because it can help you. I'll leave the next one for you to like figure out. I don't think it's too hard. The next one, though, we started mixing in numbers with variables inside of our terms, okay? And so we can multiply again. It's about things with the same base. Okay, numbers are kind of like bases, if you will. You can multiply numbers together, and then you can multiply x's together, and you can multiply y's together. But you can't. Well, if you can multiply x times y, you just can't combine them. Okay. So you don't add the exponents when you have x times y, you just combine them, okay? And we'll see that somewhere. Oh, next question. Okay, so for this one, deal with the numbers. 3 times 5, that's going to be 15. Or if you wanted to write expanded form out, okay, you do the math on it. Well, 3 times 5 is 15. And how many x's do you count? Well, it looks like there's 7 of them there. Okay, and so you can kind of start to see how this is working out. Okay, maybe what we didn't see on Friday was a question like this one. Okay, it's not that, particularly because there's not a whole lot to be done if the bases don't match. Okay, and again, the bases being here x and y. So you can't add those exponents together because they're different bases, okay? So, but if I were to write this out in expanded form, I would end up with something like 7.3 or multiplied by 3. And then I'd have an x times an x, and then I'd have a y times a y times a y. Okay, and so what do we land on? Well, 7 times 3 would be 21, x squared y cubed. Okay, that would be your new term, if you will, okay? Does anybody have any questions, comments, or concerns? Okay, and so in that box, like as a rule again, in case you lost your nice Bible sheet I gave you with all your power laws, you're going to add the exponents. Okay? Now, we're doing this because there are some like application things. If you think back to the question that I asked you all to do, well, it was the review for the second test. And there was that funny question where we had to come up with the algebraic expression. And it was a little bit ahead of where you were, but I think you could do it now. Okay, we're going to get a little practice doing that today. But for right now, I can pick a question to do. How about I'll do E, and then you guys could fill out the rest kind of just on your own, okay? So for E, like I have, this is something like in your mind, this is how I'm dealing with these questions. I always see numbers, 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 and then I see M's, oh, there's no M in the last one, and then I see N's. Okay, no N. So I'm going to multiply pink things together, I'm going to multiply green things together, and I'm going to multiply blue things together. And that's it. And you know when things are the same color or the same base, you just add the exponents. Okay? And so you're going to, if you wanted to, if this is where you're at, this is where you're at. I'm okay with this. Write it in expanded form first. -2 times -3 times 5 multiplied against M. I don't know if you need to do this or not. I don't anticipate you do, but nonetheless, it's here for you, and I'll write the answer in a sec. And then you're going to have N times N times N multiplied against, oh, there's 4 N's in the last one. Jeez. Okay, I suppose at some point, like, one of the subconscious points I want to bring up here is if you're always writing this thing out in expanded form, you're going to get sick of it very quickly. Okay, so it's okay to use it for a little bit, but questions like that hits home, and there's no saying I can't have exponents of like 17 or 15 or whatever, right? I kind of want to hit home the fact that like everything we show you in here is probably the most efficient way to deal with questions. It's not that there are not other ways to do it. It's just in the interest of time, when you have 60 or 70 minutes or 75 minutes to write a test, you don't want to do every question like this, especially if the exponents get bigger. Okay, so it's just worth your time to just like do enough questions or memorize those power laws so that when you get posed a question and the bases match, you can just apply the power laws. You don't have to write it out in expanded form like this. Okay, and then you have to do the math. Well, okay, now count up how many of everything there is in terms of variables and do the multiplication on the numbers, right? -2 times -3 is 6, times 5 would be positive 30. And then I count 1, 2, 3 M's, M cubed, and 7 N's. We all see that okay? It's getting a little crushed. Again, just trying to hit home that I don't think you want to write out the expansion, right? Expanded form all the time. Okay, does anybody have any questions so far? Aaron, did I make a mistake? Oh, did I miss? I think I missed an N. Sorry, I missed 2 N's. I missed these 2. I didn't even highlight. That's why I missed it. Better? Okay, I just missed 2. Okay. So you'll recall, hopefully you recall, I put a question up on your like test 2 review. I didn't know how it was going to go, but now I think we could deal with it based on how we've like worked with power laws and things, okay? So if I gave you something like write the expression for the volume of this thing, this little rectangular prism. Do we all know what the volume of a rectangular prism is? Anybody know what the volume of a rectangular prism is? Paulson?
Length times width times height.
Okay. So it's length times width times height. Okay, that'll be the height. Or vice versa. I suppose you can do this too. Doesn't matter. You want that to be the length. It doesn't matter how you label them. Now, here's my question. I want this to sink in for a sec because this is a common thing that goes wrong. Maybe not. Goes wrong. Okay, and I think kids just like memorize this fact. They don't actually understand why, even though it's a simple enough explanation. What would be the units for this prism? If I had actual calculation to do here, what would be the units at the end of the question, like when I wrote my therefore statement. Okay, I just want that to sink in for a sec, because I'm going to show everybody why that's the case. Because it's a power law. It's power law as to why or where it came from. And hopefully that's an understanding that you take with you for the rest of your educational career. So, what would be the units for this prism? 3D. Sarah? Okay, yeah, centimeters cubed or meters cubed or whatever, right? What's the important part in there? The cubed part. And it's cubed because it's a three-dimensional object. Right? So there's this thing, and I think maybe we have talked about this in here. Not a lot, but a little bit. It's called dimensional analysis, right? We talked about the dimensions of, something like a three-spaced object, right? So if we said that the units for each of these was going to be in meters, if I looked at like just the dimension or the, that's not right, that's a T. That's not right either. Is it an S or an a T? Which is it? Goodness me. Is that right? I can't tell today. If we looked at the dimensions, right, and we talked about like, here's an equation, we just said what the equation was. So I suppose sometimes one of the other things that I think maybe even could appear on EQAO would be like, oh, this one here, oh, we're going to trick you and make this in centimeters. Can you do this calculation if one of those dimensions is in centimeters? They've all got to be in meters, and here's why. Because if I were to plug in meters times meters times meters, what happens? Just think of this like a question from your CUDA sheet from like Friday. What's going to happen? Or just now? Yeah, Rob?
Meters cubed.
Yeah, it's meters cubed. Or you could make it centimeters cubed. Right? If you have a three-dimensional object and you're multiplying three different dimensions of meters, centimeters, whatever it is, your answer better be centimeters cubed or something cubed. That's because you're applying a power law. Does that make sense? That's my way. I never mix up units anymore, right? Like if it's an area versus a volume versus just a regular measurement, right? There's no way to mess that up if you pay attention to what's actually going on, right? And so maybe it's worth, as you do calculations through physics or science or whatever, chem, it might be worth, as you're doing your calculations, to write out the units where you plug in numbers and just pay attention to what the final answer should be. If you've done everything right, your units should work out. Okay, so that's the dimensions. I just wanted to bring that up because I have a feeling that like if you had meters times centimeters, you're going to catch that and you're going to have to know to convert that. Okay, so that it works. That's a very simplistic example, but there are often many times in physics where you're going to be given some units, some information within a question that the units don't fit the context of the question. You're going to have to do a conversion before you do the calculation. So because it'll stand out like this right here. It'll just look odd. Meters times centimeters. That's a simplistic example, but got to be careful to make sure that your units given to you in the question match before you do any calculations. That's common. Okay, and that actually ties into our discussion around scientific notation in period D today. Okay, so anyway, this relates back to the test 2 question that I gave you. It'll like just give me a volume is equal to length times width times height, and if you were to plug in length, width, and height into this equation, you're going to see the length would be 2y times the width would be 3x and the height would be 5x. So can you all simplify that for me? Remember, number variable, variable, variable. Okay, and sometimes you can multiply some variables together and others you can't, right? So you're going to get 2 times 3 again is 6, times 5 is going to be 30, x times x times y. So you could further simplify that to be 30x squared y. Does anybody have any questions? The one other thing I like to do with these questions when I give them is say, okay, my question might say, well, it'll say exactly this. Write an expression, that'll be part A. Write an expression for the volume or surface area or perimeter, whatever it is. Give me an expression. And part B will be, if x equals 2 and y equals 1, find the volume. That'll be part B. Okay? What a lot of kids will do right from the very beginning, they'll do this. They think they're smart, and it is smart. It's just cutting a corner, and you're not actually answering the full question. What they'll do is they'll take these values and plug them into here. Sorry, not for y. X for the x, and then the y. And then they just go, oh, it's 10 times 6 times 2. And they just give me the, look at all the work you've missed. Because it asked for the algebraic expression that represents the volume. So then I could say it doesn't matter what x is, what y is. You only have to do the calculation once, right? You have an algebraic expression that represents this scenario. And then I give you the conditions for the variables and you plug them in and you get answers. This is very powerful. Because it doesn't matter what x and y are. It could be anything. Okay? So it's important to be able to develop the algebraic expression so that you could take any input and get an answer. Okay? So if I were to actually do this, then I would say the volume's going to equal 30 times 2 times 1. So it'll be 60 meters cubed, call it. Yes, Opal. Oh, sorry, yeah, I missed something. You're right. Thank you. So what's 2 squared? I missed the one. 30 times 4 times 1. Everybody see? So 30 times 4 would be 120. Happier? That's a good catch. I would have left that. Okay, so you're taking your x and y values and explicitly plugging them into the equation that you developed, or the expression that you developed, okay? I'm going to hit stop there.